Chandanu Goswami. He's an associate professor at Tassim Premji University at Bangalore. He'll be talking about permafrost pathways in the Arctic and Himalaya.
Good afternoon, everybody. So after the very interesting morning sessions, I'm going to talk about a landform which is extremely important when it comes to climate change, Arctic, and also in the Indian scenario, the Himalayas. It's called the permafrost, which is a land unit or land below surface land, which is typically frozen for about 2 years or more, and in most of the cases it's perennially frozen. Basically, it's frozen for a long time. In the northern hemisphere, it's about more than 20 million square kilometer, and unfortunately, that actually got overlaid in there. But the permafrost, it's classified into 4 types. If it is continuous, we consider it's present for about 90 to 100% under the surface. For about 50 to 90%, it's called discontinuous, and for 10 to 50%, it's called sporadic. And if it is present for about 0 to 10%, it's called isolated. So you can see the you can actually on the picture there you can see how it looks like. It's there is frozen land and ice underneath the surface, and it basically got accumulated over the years because of the freeze-thaw cycle. And when it comes to the Himalayas, it has the largest area of mountain permafrost in the world, and it's heterogeneous mountain permafrost. And the major drivers of permafrost in the Himalayas is driven by globalization, infrastructure development, migration, and tourism. And the main problem when it comes to the permafrost in the Himalayas, Indian Himalayas and also the Himalayas, is that not much work has gone in there. And just imagine this piece of very important land unit sitting right next to India, which is has about 1/3 or 1/4 of the world population. And again, this is a cross section of how the permafrost looks like. It's all frozen, basically land, which is normally organic carbon rich. The one on the very subsurface, it gets thawed out during the summertime, and that piece of land, exposed land, becomes the source for all the living organisms, growth of vegetation and your microbial organism, etc. And this globally, the permafrost has about 1700 pentagram of carbon, which is equal to about 1/4 of the total soil carbon. If you look at that, these pie charts in here, that permafrost landscape has about 1% plant carbon and very little productivity. But when it comes to the soil carbon, it is frozen in there. So that's why when it comes to the climate change and how it's impacting the overall this permafrost landscape and how it's exposing it up, it becomes the main worry. Because when it happens, when this frozen permafrost landscape it thaws at an exponential rate, that's what we actually consider it to be, it becomes hotbed for greenhouse gases. And when greenhouse gases comes out of these landscapes, it warms the local climate and also it warms the overall global climate. So this is number one worry. So second worry is that once these landscapes it thaws out, it can cause thermo-erosional features, or it can basically, in simple terms, you can say it can cause erosion and big collapses, which can have a major impact on the infrastructure and also the local economy as well. And there are papers, there are recent papers that came out and which talks about impact of permafrost degradation on the infrastructure at the Arctic scale. So this led us to work on this permafrost degradation at a global scale, and we estimated that in the northern hemisphere, these degraded landscapes are about 20% of the overall global permafrost landscape. So this study was carried out, from an U.S. institute. So one thing that I want to point out is that when we did this study, we could not include the Himalayas, mainly because there was no data. So now, if this study shows that about 20% of the landscapes are seeing this thermokarst or permafrost degradation, then we really don't have any data or any perspective at hand which talks about how much of this degradation is happening in our local region, in the Indian Himalayas, or also in the Indian Himalayas. But having said that, there is Tibetan plateau permafrost, and there's a lot of work that is going in there. It is recent, that's for sure. So a recent paper says that about 500 papers were published on the Tibetan plateau. But when I think about, or when we did an assessment of permafrost research in the Indian Himalayas, it was much lesser than 50. So then where do we actually stand on this? Yeah, so we started to actually work on it a little bit. It's again scratching the surface type of thing. So we picked up an area called Chokar near Ladakh, and we did some remote sensing based assessment to see how the subsidence is in this area. So here you can see this blue color in here shows that permafrost is present in there. These are from the model global maps in all conditions, and the yellow it says it is available or basically present only in the in favorable conditions. So we, based on the available data, Sentinel-1, we did some interferometry, and then we tried to calculate the subsidence in these areas. And if you look at the 2019 figure, and again this is the subsidence from the beginning of the season all the way to the ends, which is basically from May to June. So you can, if you look at the figure in the center, which is a little bit difficult to see, but all those red points that you are seeing, those are having about 4 centimeter subsidence in those areas. Again, this has to be looked at a much finer scale. And I just want to reiterate that our problem has been, in the Indian Himalayas, that we do not have ground temperature data, which we normally need to have to understand the state of permafrost, in the permafrost landscape. So in this area, it normally remains snow-free from say June to September, and July and August are the warmest. Temperature. It's in Kelvin. I think it turns out to be about little more than 10 degrees Celsius. And we did some analysis using the data to see how the air and soil temperature has been, the trend of this air and soil temperature during the JJAS, which is the monsoon period according to the Indian climate scenario, and the October to April, which I would probably call more like a shoulder season, because normally these seasons they shift. And if you look at the figure on the left, and if you look at that 0 to 10 centimeter, there are actually 2 variables down here. One is soil temperature at different depth. The other one is air temperature. And you can see that that 0 to 10 centimeter, basically the top soil has been warming a lot. So also the other ones, but top of the land is actually warming in the last about 20 years. Okay, I need to hurry up. Again, just want to look at this. This is the temperature anomaly globally for 2020 in comparison to a recent period. When you look at our India and to that mountain area, it's about 3 degrees Celsius increase already. You look at the map on the left, which is what shows the population density, which makes us very different than some of the other like Arctic areas. And one on the right, it shows the annual land surface temperature trend. So that means red is it's increasing, green is decreasing. Most of the areas are warming up a lot. And then we're doing a lot of climate data analysis in our climate change center at Azim Premji University. What I see that in the near future, basically 21 to 24, we are already in there almost. So these areas, mostly Ladakh, is going to see a lot of rain. I'm talking about rain for JJS, rain for basically southwest and northward monsoon and annual. So the question is that if these areas are going to have a lot more rain, and we're also seeing increase in extremes, so actually what is this going to do to the permafrost landscape that we have? There are 3 pictures. The one is from Charsky on the left. The one below is from Longyearbyen. The one on the top right is from Josimot. Josimot happened, subsidence happened. We did not really talk, I didn't really see a single word of permafrost coming up when he talked about Josimot. If you compare these photos, they are very, very similar. We do understand that in India we have permafrost not in continuous manner, we have permafrost in isolated and sporadic manner. But is there a relationship permafrost degradation to the subsidence that we are having out here, right? Yeah. So having said that, I think we should start asking about the right questions, and thank you very much.